While we're here, we might as well wrap up this unit for right now in talking about types of chemical reactions. So, this is going to be where we end this semester. It's getting towards the end. Um, we just don't have enough time to do anything else this semester because we have a lab and a final review and another Unit 4 tests and all these things to do before then. So, we're going to talk about types of chemical reactions today as well. And then you guys will have a little bit of practice on this next time in class. So if you're watching this with the balancing equations day, we will do this next class. If not, this is what we're going to do the day after. So this is the only slide. We have 5 different kinds of chemical reactions that we're going to look at. I'm going to start here with synthesis. So synthesis is when 2 atoms combine to form 1 molecule. So this is talking about like 2 separate atoms, 2 singular elements that are in the reactants that are going to combine to produce a molecule. So they have bonded together in that process. So you start with like an A and a B separately that yields an AB molecule together. Decomposition is going to be the exact opposite of synthesis. So one molecule is going to be broken down into 2 atoms. So whatever you start with is going to be broken down into its individual pieces. That does not have to be like a singular atom. It could be, or just 2 things bonded together. You could have 3 elements bonded together and then it breaks it down into 2 different parts or 3 different parts. So anytime you're breaking down a molecule, you are having decomposition. Single replacement reactions are when a single atom switches places with one atom in a molecule. So here in this example, we're looking at the green one here. So you have a singular A plus a BC molecule yields a singular C plus a BA molecule. So if you look closely there, the A replaced the C. Another way to kind of think about this is with a relationship. So if you have 2 people that are dating and then like a homewrecker comes in and wants to take the person's spot, let's say they steal the girlfriend. Now the old girlfriend is kicked out and the new girlfriend's in. So that's a single replacement reaction where one part of the molecule is replaced. So then the double replacement reaction is kind of exactly what it sounds like. So one atom from each molecule is going to switch places. So here in this example, we have an AB molecule plus a CD molecule is going to yield an AC molecule plus a BD molecule. So you had the C and the B switched places. And another kind of real life example of that would be if you had like 2 couples and they switched partners. So if you had 4 people and they decided to switch the people that they were dating, that would be kind of your double replacement there. So something from both sets of molecules or compounds is going to be in a new place after the reaction happens. The last one is going to be combustion. So this one's a little harder to identify. You're looking for a specific thing or a specific set of molecules in your products. So the products always will include carbon dioxide and water. Okay, so you'll have whatever your reactants are, and they will yield carbon dioxide and water. It won't only be carbon dioxide and water. There will be other parts of the formula from the reactants that will show up into the products, but part of the products will include carbon dioxide and water. So if you see those as part of your problem, then you're going to end up with combustion. Another way you might be able to identify combustion, sometimes there's heat involved, so that might be a clue that it can be combustion, but that's not exclusive to combustion. So you could add heat in other formulas, but it might be a clue that combustion is happening. And that is the only slide. So we'll do some practice with this, and it's just a matter of the rearrangement of the different equations.